Hello dear students, you are welcome to series number 4 of our lesson on nuclear chemistry. My name is Ibukunolu Ademola. By the grace of God, this is the last lesson and our topic for today is half-life. Thank you for listening. Dear students, you are welcome back. This is lesson number 4 on nuclear chemistry and today we'll be looking at half-life. My name is Ibukunolu Ademola. You are welcome. Half-life can be defined as the time it takes a given radioactive element to decay by half. Let us consider this graph. The original mass of a given mass of element is 100 grams. So the time it takes this mass to decay by half, which is 50, is 12 minutes 30 seconds. And the time it takes the mass left, which is 50 grams, to decay by its half is another 12 minutes 30 seconds. So it will take 50 grams to also decay to its half, which is 25 grams. It will take it 12 minutes 30 seconds. And the mass left, which is 25 grams, it will also take it another 12 minutes 30 seconds to decay by its half, which is 12.5 grams. And it will take 12.5 grams, which is the mass left, to decay by its half, which is 6.25, another 12 minutes 30 seconds. So the time it takes this mass to decay by its half and the mass left to decay by its half is what is called half-life. Let us consider another graph here. If the mass of the element is 10 grams, it will take the time it takes this mass to decay by half is half-life. So if it takes it to decay, the time it takes it to decay by its half, which is 5, is equal to the time it takes 5 to decay by its half, which is 2.5, and the time is also equal to the time it will take 2.5 to decay by 1.5. So that is what is called half-life. The time it takes an element to decay to its half. How do you calculate half-life? You can calculate half-life using this formula: x is equals to m over 2 raised to the power n, where n is the period of decay divided by half-life, and x over m is equals to fraction that is left, while m minus x is the quantity that has destroyed. M minus x over m is equal to fraction that has decayed. But what is n? N is the number of half-lives. M is the initial quantity, that is the initial mass or whatever is given at the beginning, while x itself is the quantity left after a given number of half-lives. So that is the formula that can be used to calculate the half-life. Let us look at this example. The half-life of an element Z is 10 days. If there are 10 grams of Z initially, what would be its mass after 40 days? So how do we solve this question? Let us look at this method. To solve this question, in finding the mass that will be left after 40 days of decay, we know that n is equals to the period of decay over the half-life, and that will give us 40 divided by 10, which is for this 4. And the formula we are using to calculate the mass that is left is x equals m over 2 raised to the power n. Remember, x is the mass left, while m is the original mass and n is the half-life. So substituting m, which is 10, and n, which is 4, we have 10 divided by 2 raised to the power 4, which is equal to 10 over 16, and the mass that is left is equal to 0.625 grams. If we apply the second formula, what do we get? In 10 days, 10 grams of Z will decay to its half, and don't forget that half of 10 is 5 grams, and that represents the first half-life, that is the first decay. And in another 10 days, the mass that is left, which is 5 grams, will also decay to its 5, and that will be what? 2.5 grams. That is the second decay, which we can refer to as second half-life. In another 10 days, making 30 days now, in another 10 days, the mass that is left previously, which is 2.5 grams, will also decay to its half. So half of 2.5 is 1.25, and this is the third decay, which we can refer to as the third half-life. And in another 10 days, 10 days of the first time plus 10 days of the second time plus the 10 days of the third time plus the 10 days of this fourth time, now making 40 days. So in these 40 days, the fourth 10 days, the mass that is left, which initially, which is 1.25, will also decay to half, which is 0.625, and this is the fourth decay, which we can refer to as the fourth half-life. So the mass left is 0.625 gram. That is the mass left after the 40 days, which represents 4 half-life. Here is another example. The half-life of thorium-234 is 24 days. Suppose the original mass of pure thorium-234 is 100 grams. What mass is left after 96 days? We can as well solve this question using two different methods. Let us look at method number 1. Remember, we are asked to find the mass that is left after 96 days of decay. So the original mass given to us in the question is 100 grams, while we can get the number of decay, or period of decay rather, by the period of decay over the half-life, which is 24 days, and that will give us 4. So n is equal to 4. So we go back to our formula, which is x is equal to m over 2 raised power n, where m is 100 and n is 4. So that will be 100 divided by 2 raised power 4. And that is going to give us 100 divided by 16, which is equal to 6.25. So the mass that will be left, the mass of thorium that will be left after 96 days of decay is 66.25 grams. It means that in 96 days, the mass of thorium, which is 100 grams, will decay to 6.25. That is the decay. It will decay to 6.25 from 100 after 96 days. We can as well use this method, the second method, which I call the equation method. So in 24 days, 100 grams of thorium will decay by its half. Don't forget, half of 100 is 50. That is the first decay, which we can refer to as first half-life. In another 24 days, the mass that is left after the first decay, which is 50, will also decay to its half. And half of 50, all of us know that is 25 grams. I'm sure you are all aware of that. Okay. So that means in 24, that is 48. In 48 days, 100 grams of thorium would have decayed to 25 grams. That is what it means. So in another 24 days, the mass that is left after second decay or second half-life, 25, will also decay to its half, and that is what? 12.5 grams. So what it means is that in 24 plus 24 plus 24, that is what? 72 days. You are too good. In 72 days, 100 grams of thorium-234 would have decayed to 12.5 grams. Okay, so in another 24 days, the mass that was left after the third decay or third half-life, which is 12.5, will also decay to its half, which is 6.25 grams. And that represents what? 24 days in 4 times, or 24 days in 4 places. That is 24 plus 24 plus 24 plus 24, making 96 days. So 100 grams of thorium-234 will decay to 6.25 after 96 days. And this represents 4 different half-lives. So this is the equation method. If you apply this method or the first one, you will still arrive at the same answer if you are doing the right thing. Here are the uses of radioactivity and nuclear reactions. It is used for curative purposes in medicine and as a treatment of cancer. It is also used in carbon dating to determine the age of ancient specimens. Radioactivity is also used as a source of energy in nuclear electric power plants and is also used for food preservation by destroying the harmful bacteria. And it is also used in atomic bomb. And lastly, radioactivity is very useful in agriculture, either for boosting the crop production and for killing the bacteria and all of that. These are the uses of radioactivity and nuclear reactions. In our lesson today, we've been able to define half-life. We've also been able to do some calculations on half-life, and we have also looked at the uses of radioactivity and nuclear reaction. That will be it for today. God bless you all. Here is my email address. You can contact me on the email address displayed on this screen. My name remains Ibukunolu Ademola. Thank you for listening. God bless you all.